Good afternoon, Flutter developers. So we have talked about Flutter a lot, right? So it's time to go to the fundamentals where everything becomes in place. So I would like to talk about Flutter solid principles and how they can make your code that is more maintainable, extendable, and reusable and understandable. So my confidence right now has crashed like the cryptocurrency nowadays, and yeah, this is my first time on stage and addressing this huge crowd, but I would love to have your support. So yeah, this is me, and most of the things that he has already mentioned. So I'm a mobile app enthusiast, and I started my career as an Android developer around 8 or 9 years back. So just like every other developer, I used to make mistakes, common mistakes, and which can be a huge baggage once your project or an application becomes larger. So I tend to write a class that used to have 2,000 lines of code. Yeah, So right now, if you look at that code, you will laugh at yourself. The second thing, what I was doing is tightly coupling the classes, and again, that's a big mistake. That if you have any change in your system, then it is going to blow up. So I was not thinking about the abstraction. I was not managing the inheritance properly, and I was scratching my head that how can I get out of this bullshit, or how can I resolve these issues which are becoming a bottleneck to the production releases or managing the timelines. So some fine day, I got to know about. Yeah, I didn't open this slide. Sorry. So yeah, some fine day, I got to know about solid principles, and solid principles were really a savior for me, and it's just the savior in the slide. So we will deep dive into each of the principles in detail if the time allows, and if not, I will be around, and if you want to learn more about that, I would love to address your questions or share details on each of the concepts. So the first concept is single responsibilities, as he has already mentioned. So it states that a class should have only one reason to change, or it should do probably a single thing, or it should have a single responsibility. So look at this. This is me 7 or 8 years back. I was not happy at all. So if we try to understand in action that, I would love to build a use case of this event and build a mobile application out of it. So as you can see, to give easy authentication to user, we thought of providing Facebook authentication, as you can see right here, right? So this is a login screen, and it does rendering the UI as well as it authenticates user by authenticating user to Facebook and fetching their profile from Facebook. So if you can imagine that if we have LinkedIn sign in, and then there can be Google as well. So just imagine how long this class would be, or login screen, and how many things it would be doing. So instead, what we can do is we can apply single responsibility to classes, and it's just not restricted to classes. You should apply it to the function level as well. So as you can see here, this is the mistake. Though I have implemented solid principle, single responsibility principle, but though here I have made two things to do in just one method or a function. So how we can correct it? So now it's a correct code of snippet wherein we have 3 different methods which do individual task or a single task, and we have a Facebook auth helper that is responsible for only authenticating and signing out and fetching the user profile. So now we would talk about, so yeah, these are the goals. So as I mentioned earlier that I was writing 1,000 and 2,000 lines of code. So those classes are called God classes. So single responsibility principle will restrict the God class, and it would increase the maintainability as well. Now the second concept is open close principle, and it states that all the software entities should be closed for modification and open for extension. So what does it mean? So as you can see in this image that there's a plug socket on the wall. So if you need, if that is full, and if you need a more socket, I mean if you want to charge your mobile phone, then you won't dig the wall and just connect the socket to the wires, right? You would use an extension. And if you need another, then you would use another extension. So this is how it states that you won't change the core feature, and you won't change it, but you would extend it to leverage those features that it has. So again, let's get back to our use case wherein we are building the Flutter Conf app. So we have two different entities, right? One is speaker like me, and the other is the team who is managing the whole event. So I got logged into the app. I saw the who are the speakers and who are the team that are managing the event. So I got interested. So to build that UI or module, what we can do is we can create a person class that holds basic properties of a person like name, organization, and profile image. But as the concept suggests that we shouldn't modify it. So what will we do about a speaker session or his timing? So what we can do is we can extend that class and create a new class that is called a speaker. And we can have those property managed right in there. Same goes for team as well. So that's how you didn't change the base class or a core class that is used in your feature or in the code. So again, the mistakes, if we connect back, then I made a mistake that I made classes tightly coupled, so that if I change one class, it would affect the other class, and my production app just blow ups. It can avoid bugs as well, and it increases the reusability and maintainability. The third is Liskov substitution, and we can define it as a derived or a child class must substitute their parent class. So this helps to set up a valid hierarchy or valid inheritance in your application. So as you can see, there are two bulbs. One is conventional and the other is colored or a decorative bulb. So if the conventional bulb is the base class, you won't be able to replace that with the decorative class because it won't serve the purpose, right? That used to emit yellow light and it's emitting a colorful light. But in this image, the other bulb can be replaced on the position of parent. So now let's get back to the use case. Now I'm pretty much interested that I want to attend the conference, right? So the thing this team will ask you for is to buy the ticket. So we need to prepare a feature for ticket, and ticket has basically three things: name, what is the name of the ticket, like early bird and the regular. Then there's a price and there's a description, that what will you get for the amount that you are paying for a specific ticket. So I've created a class, and I have created another class for regular. So as you can see here, that all the inherited properties like price, name, and description, both the classes are implementing it. So if we look into the code snippet, that if there is a booking feature, so doesn't matter what user selects, either regular or the early bird, but you would be able to they would be able to replace by the ticket, and you can take it forward for let's say payment gateway. So as I mentioned while I was talking, so these are the goals that we can achieve. I won't read it loud. Now, if we go to the fourth concept, that it states that it's interface segregation, and client should not be forced to depend on methods they do not use. It's like I shouldn't be given much work, right, which I cannot work, like managing the conference. I won't be able to do that. So yeah, the graphic states that, let's take an example, that if we are building a software for a car assembly line, let's say, then humans and robots both work together, as we know that. So if we have created, a fat interface that has methods like work, lunch break, and charge your battery. So human says, I don't have a battery. How would I charge my battery? And same goes for robot as well. So that is a wrong implementation. Instead, we should have single interfaces for each of them. And this principle is similar to single responsibility principle. And this principle applies to the interface as well. So if we get back to our use case of building this app, so we have a team, right? Sorry, this is a bit lengthy. So the team has a, okay, so I just forgot it. So we have, I have created an interface called interface conf, and it has these setup agenda, attend, manage conf, and present session. So there are 4 methods I have defined into it, and this will be considered as a fat interface. Now, as we can see, team can set up the agenda, they would be able to attend the conference, they would be able to manage the conference, but they won't be able to present the session, right? So this is a wrong implementation. Same goes for speaker as well, as I mentioned for the team. Now what can be the right implementation? I have created 3 different interfaces specific to their responsibilities, just like this. The interface attend conf will be having this attend method, and interface manage conf will be having these 2 methods. So the team won't be having a method that they should not implement. Same goes for speaker. So I've created another interface called present session, and it does implement only 2 of them. Now this is the last concept, and it states that, I mean, it's very tough. Its definition is very tough. High-level modules should not depend on low-level modules. Both should depend on abstraction. The first time I read, I was like, what is this? Yeah, so for this, I would like to explain using excavator. So excavator can perform multiple tasks, right, depending on the tool it has. Like it can dig it up, it can lift it up, or anything. So for each of the tool, you don't need to change the console, right? Or the console doesn't need to know that which tool they have been working on. So they both depend on the abstraction. So high-level module and low-level module. High-level module would be the controller. Low-level module would be the thing that actually does the action, and those would be these tools. And abstraction can be, a controller. I don't have technical knowledge of excavator, but both of them depends on the abstraction. So now the user has logged in and they are interested. They are going to book the ticket, but the last thing that will be there is payment. So how can we implement the payment? So for that, there is a payment class, and that is an abstract class, and we have a pay method. And now I have created 2 classes, that is payment via card and payment via UPI. Both implements payment. If we take another step, then I have implemented another concept called design patterns, and this is a factory method, and it comes under creational behavior of it. So depending on the type that user selects, it would return the instance of the class if it has to be done via payment or via card or via UPI. And if I go back, then the implementation of payment via card will be here, and the implementation for payment via UPI will be here. So you can consider it if you are having multiple payment gateways as well. So now if we extend that book ticket method, then this will be the code snippet where we are providing the abstraction. So book ticket or booking class won't be able to know which thing that we are using to get the payment done. It will be always, there would be abstraction, and here the pay method would be the abstraction. So booking class here is a high-level module, and payment via card and payment via UPI would be the low-level module. And yeah, using the abstractions, right, and not depending directly on each other, that would decouple the dependency, and it would help you a lot while your code is in production. So yeah, see this man. This is just to catch your attention because, the 5 principles are very boring, I would say. So yeah, so implementing solid principles should not be your goal. Your goal should be how you can make your code, the code that should be more maintainable, that should be reusable, that should be readable. So you should think twice, right, before implementing. Not all the cases need solid principles. If you start implementing them in each and every code or a file or a snippet, then you would be in a problem, right? You will over-fragment your classes where it was not required. So this is a summary that how solid principles can help you. They can help you make code more maintainable. But yeah, I won't read it loud because it's right in there. Sorry for that, I am having dry throat. And yeah, thank you. That was the knowledge that I wanted to share with you. Now we can have Q&A sessions and no tough questions, please. Thank you so much. And yeah, do visit the Wise booth. We have exciting swags and we are also hiring, and we have some exciting things as well. To get to know that, you can visit the Wise booth as well. Thank you so much for your support. Now I feel like I'm rock climbing like cryptocurrency a year ago. Thank you so much. Excuse me. Question.
When you're using something like provider, right? I hope you guys, do you use provider? I don't know if you use provider. But what happens when I use provider is, my provider function tends to go like very long. Eventually when the app completes, it's like very long. Do you have any tips to for state management especially, how do you really implement this solid principles? Like state management for me is messy thing.
Yeah.
And also we don't usually talk about architectures. Like what architecture would you recommend on your experience to use in Flutter for easily maintaining code? That because you mentioned somewhere MVC thing with the excavator thing. So what would you recommend?
Sorry, I couldn't connect your question to the example that you mentioned.
So state management function, state management is a messy topic, and I feel like it's a messy topic in Flutter.
Yeah, it does, but for the first thing, I haven't tried provider. I'm aware of GetX. So if that is the core of the question, then we can talk about it later as well. But I would suggest if you have any question related to this topic, then that would be great.
Is like how can you? My question is basically like how can you extend solid principles to state management?
Yeah, that's a tough question. Yeah, but we can connect outside. I will be available at the booth, and we can have a discussion around it, and we can come to a conclusion.
It's all
because
right.
I don't have a specific answer to that right now.
Yeah, that's okay. That's okay.
Yeah.
Fine. Cool.
Thank you.
Yeah, hi.
Hi.
Is there any performance issue because you are giving multiple methods in a classes? So will there be any performance issue?
No, there won't be, because if you look back, right, the solid principles are, were fundamentals and are fundamentals after 2 decades as well. They are around us since 2 decades. So I don't think so there would be any performance issue if you, implement those features. But Yeah, I think there would be performance improvement if you use these features.
Okay. Actually, if you are writing multiple methods in a
Can you
class,
speak a bit louder? Sorry.
if you are writing multiple methods in a class, if it is not compiled to machine code, then there will be a performance issue actually.
Yeah, exactly.
Because it's jumping.
Yeah. So what I mentioned earlier, that you should think twice before implementing them as well. So there are certain cases I have seen that the developers are over factoring or over fragmenting the classes where it is not required. So it will be always contextual that whether should I use this principle here or not. If you feel so, then you can. If you don't feel any need of it, then you can, just use the traditional methods. So it will always remain the contextual of what you are building and where that product is.
Thank you.
Yeah. So do we have any question, or should I get back to my team? Okay, thank you. You are a great crowd, and you you make me so comfortable that, as I mentioned, my confidence got rocked. Thank you so much.